For centuries, humanity has accepted death as an insurmountable boundary, a point of no return. The heart stops. The brain ceases to send signals. The body grows cold. And then everything ends, or does it? In April 2019, a group of scientists from Yale University shook one of humanity's oldest certainties, that death is irreversible. Led by a calm, brilliant, and quietly revolutionary man named Nenad Sestan, what they discovered that year not only shook the scientific world, it also forced doctors, bioethicists, and philosophers to rethink a question we thought was already answered: where does death truly begin, and where might it end? Nenad Sestan was born in Croatia in 1970. From a young age, he showed an insatiable curiosity to understand the human brain. Not just because of its biological complexity, but because of what it represented: the seat of consciousness, memory, and identity. He trained in medicine in his home country, but soon his passion for neuroscience took him to the United States. There, he specialized in brain development and neural connectivity. He was, without a doubt, one of those scientists who preferred microscopes over the spotlight. But fate had other plans. In 2019, Sestan and his team presented the results of an experiment that left the world breathless. For years, they had been developing a system called BrainEx, designed to partially restore blood circulation and some cellular functions in brains that had been dead for hours. And they succeeded. The procedure was as simple in its approach as it was chilling in its implications. They obtained pig brains that had been taken from animals slaughtered in abattoirs. For hours after their death, they connected these organs to a machine that pumped a special fluid, a kind of blood substitute loaded with nutrients, drugs, and compounds designed to prevent inflammation and cellular degradation. For 6 hours, that liquid flowed through the brain's arteries as if the brain were alive. And the most shocking thing wasn't that the tissue structure was preserved. It was that some cellular functions began to reactivate. The glial cells, essential for supporting the nervous system, started to respond. The neurons, those basic units of thought, showed synaptic activity. Even the vascular system regained flow and immune response. All of this happened in a brain that had been dead for 4 hours. But there's an important detail. Despite this partial recovery, there was no sign of consciousness. No brain waves indicating perception, memory, or thought. And that wasn't an accident. The team had taken every precaution to prevent a full reactivation of the brain. They didn't want an animal, even if it was just an isolated brain, to wake up in absolute darkness and isolation. What they were after wasn't the resurrection of consciousness, but a proof of concept, to show that brain cells don't die instantly after cardiac arrest, as was always believed, but can instead enter a state of slow degradation, and that if you act quickly, it's possible to reverse some of that damage. The news hit the scientific world like a bomb. Did this mean we could resurrect brains? Or at least keep alive organs that until then were considered beyond recovery? For neurosurgeons and transplant specialists, it was a door opening. For bioethicists, it was a troubling dilemma. And for humanity, it was like sneaking a glance at a future that until recently seemed reserved for science fiction. The idea that death could be, in certain contexts, a negotiable condition. The story doesn't end there. 3 years later, in 2022, Nenad Sestan and his team took an even bigger step. It was no longer just about brains. This time, they developed a technology called OrganEx, which aimed to restore cellular functions throughout the entire body, not just the brain. They used a similar model, a complex chemical solution, pumped by a machine designed to replace the heart and lungs. The goal? To revive entire organs from dead pigs, including the liver, kidneys, heart, and yes, the brain too. The results were even more astonishing. The organs treated with OrganEx showed cellular activity, recovery of certain basic functions, and even involuntary muscle movements. In some cases, the pigs made spontaneous jerks, as if their bodies were trying to wake up. Although no consciousness was detected, these jerks were enough to stop the scientists in their tracks. Because deep down, everyone knew they were playing with the darkest and most unknown limits of human biology. And that this kind of discovery doesn't just change medicine. It changes the very concept of what it means to be alive. The most unsettling thing is this: many organs, upon death, don't die instantly. They simply shut down like a disconnected power grid. But if someone knew how to reconnect the power, could they start working again? Nenad Sestan seemed to have found the switch. What Nenad Sestan had demonstrated was something many were reluctant to accept: that biological death wasn't a red line, but a curve, a slope. And that, if you acted at just the right moment, you could climb back up it. But of course, keeping cells alive is one thing, and bringing a person back is something else entirely. No one was talking about Frankenstein-style resuscitation. But the obvious couldn't be ignored either. If an organ can remain functional after death, if it can recover, then how much time do we really have to save a life? Minutes? Hours? Days, in a not-so-distant future? Sestan's experiments quickly unleashed a whirlwind of ethical questions. If a dead heart can beat again, if a dead liver can go back to filtering toxins, if a dead brain can show cellular activity again, how long should we keep considering a body as dead? And who gets to decide? The implications for organ transplants were enormous. If you can restore the function of a heart that has stopped beating, the window for extracting and transplanting it multiplies. Thousands of lives could be saved. But if you can keep a body functioning after death, what does that mean for organ donation? Could a technically dead body be kept operational to preserve its organs for days? Would we stop needing living donors for certain organs? These questions aren't science fiction. They're very real. And Nenad Sestan knows it. Despite all the media buzz, Sestan has remained calm. True to his role as a scientist, he's insisted that his research isn't aimed at reviving consciousness or challenging death as a philosophical concept. What he's after is something very specific: pushing the boundaries of modern medicine. And he's doing it. With OrganEx, he's opened a door to preserving organs for much longer. Instead of being limited to minutes or hours after death, we could be talking about days. That completely transforms transplant logistics, the way we handle emergencies, even the treatment of severe accidents or prolonged cardiac arrests. But the real sense of vertigo comes when you imagine the future. What if this technology is perfected? What if one day we can restore more complex functions, like communication between different regions of the brain? What if a body that has been dead for 5 or 6 hours could be brought back to an operational state? This isn't just about science. It's about philosophy. For some, it's about religion. It's about the deepest part of our identity as human beings. Do we want to live in a world where death is no longer final? Where post-mortem time is just a window, not an ending? The story of Nenad Sestan is also a story of warning. Because while his research has the potential to save thousands of lives, it also forces us to face an uncomfortable mirror. What happens if we use this technology for the wrong purposes? What if we try to keep bodies alive without consciousness? Or if it's applied to humans without enough ethical oversight? In his publications, Sestan has been clear. No experiment with revived animals showed any signs of consciousness. And that's something his team deliberately avoided. But what if someone in another lab isn't as careful? At its core, the most unsettling thing about all this is that we've started to figure out how to reverse biological death, without yet having a clear definition of what life is. And that's where the true power and danger of Sestan's discovery lies. We're no longer talking about keeping tissues alive in a lab box. We're talking about changing humanity's relationship with its own end. The media impact has been such that many universities, bioethics centers, and medical organizations are now rewriting their protocols. The line that defines brain death has become more blurred. And even though for now the advances are only being applied to pigs in controlled environments, the question is already on the table: how long until we see these technologies used on humans? No one knows. But the truth is, that possibility no longer belongs to science fiction. It's here, among us. Silent, real, and moving forward. Meanwhile, Sestan continues his work at Yale, away from the spotlight, in his lab, surrounded by tubes, monitors, and preserved brains. He doesn't give many interviews. He's not looking for headlines. But he knows that what he has discovered could change everything. And maybe that's why he stays calm. Because he understands better than anyone that when you're playing with the threads of life and death, there's no need for drama. Only precision and a very clear awareness of the ground you're treading. The future of medicine might not be about curing diseases. Maybe it's about reversing the very end itself. Perhaps, in a few decades, when someone suffers a cardiac arrest, people won't react with the usual desperation, but with a different mindset. One where time is no longer the enemy, but a resource that can be stretched. A resource that can be conquered. But we also have to ask ourselves, do we want to do it? Do we want to live in a world where death isn't a limit, but a technical obstacle that can be solved? Where life is extended indefinitely and, along with it, so are pain, uncertainty, and the burden of existence. Nenad Sestan's experiment doesn't just challenge the limits of the body, it also challenges the limits of the soul. And although we're still far from bringing the dead back to life, we may have taken the first step toward understanding that death, like everything in science, can also be a moving frontier.